To the Institute for Product Leadership. Today, it is our great pleasure to host the monthly Product Leaders webinar on product management in the era of data science by Mandar Parikh, the Vice President of Product Management and Engineering at Palo Alto-based Entytle. Before we get going with tonight's webinar, I'd like to give you a small introduction about the Institute of Product Leadership. We are a global business school for technology and product innovators operating out of several campuses in India as well as in the US. Our corporate alumni are now spanning over 200 companies across India and abroad. We run programs ranging from an 18-month executive MBA to 3-day workshops on product management professional essentials. Tonight, we're also very proud to announce our first e-learning course on product management fundamentals. This is our first foray into e-learning, and we're eager to have all of you sign up and take a look at our first course. To sign up, do head over to lms.productleadership.com and follow the steps on the site there. We also are giving our registrants tonight another way to sign up and get a discount on the e-learning course. Head over to the Product Leaders Consortium, our LinkedIn group, and post questions for our speaker tonight at the group. And the first 20 lucky questionnaires will get discount coupons to take in our e-learning course. So we look forward to interacting with you on our LinkedIn group. One lucky webinar attendee tonight will also get a copy of Data Science for Dummies, a book that Mandar recommends. For your questions, like I already mentioned, please head over to our LinkedIn group, or you can also use the chat window available in the GoToWebinar panel. You can also tweet to us at hashtag prod events @prodleader or our hashtag and handle on Twitter. Without further ado, let me introduce Mandar Parikh, our executive guest speaker for tonight. Mandar is calling in from Palo Alto in California. He is the Vice President for Product Management and Engineering at Entitled, a data science startup. Mandar is a full-stack product management leader, having spent 18 years in tech and having led the function at various SaaS leader companies like Zuara and Aviso. He's also launched Salesforce high-tech vertical and co-founded and run a boutique SaaS product company. Mandar has an MBA from Chicago Booth, an MS in computer science from Stanford, and a BS in computer science from Rutgers. It is my privilege to now hand over to Mandar. Over to you.
Thanks, Padmaja. Give me 1 second while I bring up my screen. Can you see my screen?
Yes, Mandar.
Okay, perfect. Thank you for that introduction. Just to kind of add a little bit to that, so as Padmaja mentioned, I'm currently VP of Product Management and Engineering at Entitled. Entitled is a Series A startup. We are a data science enterprise SaaS application. We provide revenue optimization solutions to the industrial manufacturing industry. And I'm actually a software engineer turned product manager, right? So the majority of my career has been in enterprise software and SaaS. As Padmaja mentioned, I worked at Salesforce.com, where I ran the high-tech vertical. I then joined Zuora, which was a spin-off from Salesforce, and I was Senior Director of Product Management there. And for the past 5 or 6 years, I've been fortunate enough to be working with what I loosely call data science-enabled products. And so, which is what brings us to today's webinar. Really excited to be here. I'm very passionate about building products, and more so, I'm really excited to be talking about how to build great products with data science. And so that's the topic of the webinar today. And what I have on the screen is pretty straightforward agenda. We've already done my background. What I want to do next is kind of really start with, what is data science? What are data science enabled products, right? And for the rest of the conversation, it's important to set up some context. So I have a very abbreviated primer on data science, if you will. And, rest assured that this presentation is, from a practitioner's perspective. So it's not, theory. It's, I've made it concrete, and hopefully there are, enough examples for everybody to follow along. I'll then get into kind of the bulk of the presentation, which is around designing products with data science and what are the strategies for success. I'll talk a little bit about what the pitfalls are, and then I'll move to kind of beyond just the product itself, and I'll talk about how to engage with data science teams, how to talk about the data science in a product marketing capacity, and then I'll have one final slide on what I consider kind of, essentials or toolkit for product managers. So with that, so let's get started. So first question is, what is data science, right? So a lot of people will actually say that data science is not really a science, right? It's it's not really science in the sense that scientific theories are falsifiable, right? And they are, they have to be tested, and they have explanatory power. Why do stars explode, and so on and so forth. And so in that sense, it's not really a science. And so what is it? And so if you Google data science, you'll find plenty of kind of definitions of data science. What I like to go with is just a simple statement, which is that I think of data science as an approach that takes large amounts of data and extracts patterns and insights from it, and makes predictions based on the data to impact some business driver, right? And obviously, we're going to talk a lot more about this. We should also kind of note that data science is not necessarily new. These are it's basically a new term for statistical techniques that have existed for many decades. So with that as a background, okay, so what are data science enabled products? I don't have a better term for this. Hopefully somebody in the industry comes up with a term that explains this, but I think of it as, my working definition is that if you have a product where data science is at the core of the offering, where the data science offers some differentiating IP, that I think of as a data science enabled product. And as I said, data science has been around for decades, which means that you have lots and lots of products with data science in them all around you. And so I've just, just to kind of set this up, I've taken, 3 examples just to set up context for us in terms of, what do these products look like, right? And so I picked LinkedIn and Uber because they're, really well known. Everybody on this, on the webinar have undoubtedly used the products. And the other example is Salesforce, not only because they were my prior employer, but also because I think it's a good example of something on the kind of the business side, right? So LinkedIn and Uber are more examples on the consumer side. Salesforce is an example on the business side. And throughout this presentation, I'm going to keep bringing up Salesforce and to show kind of examples of that. And just a caveat, there's certainly lots of applications of AI, right, including natural language processing, image recognition, and all of them are incredibly important. I don't have experience directly in them, and it wouldn't be possible to cover everything in any case in the course of this webinar. So I won't be talking about certain aspects of AI. So just to kind of set that up, I should also kind of mention, right, the topic that we've selected is kind of broad, right? So so my talk is also going to be kind of broad brushstrokes, but again, hopefully we get into enough details to keep everybody engaged. Okay, so let's look at those examples, right? LinkedIn, right? LinkedIn is this, is a good example. They were kind of at the forefront of modern day data science, right? They were one of the first companies to put together a strong data science team. DJ Patil, who was a chief data scientist in the Obama administration, he was also at LinkedIn. When you use LinkedIn, you see the data science at work, right? So the graph search that you do on LinkedIn, that's data science behind the scenes. If you're using the recruiter product from LinkedIn, that's data science behind the scenes. the people you may know type of functionality that you'd see on LinkedIn or other social networks. These are all examples of data science, inside the products. Uber is the other Uber example of data science, right? Lots of applications of data science at Uber. So one of the use cases that we don't normally see as riders is this idea of driver positioning, right? How do the drivers know where to wait for customers? What's the best place for the driver to wait to maximize their ride revenue, right? That is driven by data science algorithms in the back end. This whole idea about demand forecasting of rides, that's driven off of data science, based on that search pricing, estimating ETAs, and so on and so forth. So these are all probably obvious to you. On the business side of things, Salesforce is an interesting example. When Salesforce first started, it was a contact manager. It was a CRM system. It was a data entry system. There was absolutely no data science in there. Over the last some years, they've shored up a data science team, and they've brought data science into the product itself. It's called Salesforce Einstein. They call it out in their app, and so the screenshot you're seeing is a lead in their Sales Cloud, and you see a lead score of I think it says 83 or 93, and we'll see a lot more of what this means for users. So these are just some quick examples to kind of set context for us for what data science enabled products are. Okay. So let's get on to kind of just doing this a mini primer on data science. So this is what I want to do is I want to establish some terminology that we're going to use in the rest of the webinar. So that's that's the motivation to doing data science primer. This is not intended as a crash course on data science, just to set up some terminology. So so at the very core of it, data scientists, what they do is they're building models that work on large data sets, and they make predictions from that, right? So if you think of the data sets as rows of data stored in a table, then every column is what is called a feature, right? The models that we build need to shortlist these features that will be used to make those predictions. And so that shortlisting of features is called feature selection, right? So this is really critical. This is a colleague of mine once said, right, the art of data science is really to figure out which features to use, right? So I'm making it sound simple, but really this is at the core of what data science does. So just to kind of give you set up an example, let's say you had a data set about customers, and we were predicting which customers are more or less likely to buy a certain type of product. And so then we'd have to figure out which of those features are statistically important in making that purchasing decision, right? And so we might decide that, let's say, age of the customer is a feature that we would include in our analysis. We might say the color of their hair is a feature that we might include, but for some reason we might say the zip code that they reside in is not a feature in our prediction, right? So this process is what we call feature selection. So once we have our features, we build different types of models, and there are, and these models or algorithms fall into a couple of different types of categories, right? So the first one is what you'll hear often called unsupervised learning, pardon me. So what is unsupervised learning? Simply put, it's basically a set of algorithms that figure out what patterns are existing in the data. So they, so they go into the data. Is there a question? I'm sorry. So so they go into the data and don't know a priori what types of patterns exist, but they figure out what the patterns are that to look for, right? The other set is supervised learning, right? So this is saying using the patterns in the data, let's make predictions on that, right? And so there, again, lots of kind of general purpose algorithms that have been developed, and you'll hear these names kind of mentioned often. So there's random forest, gradient boosted machines, lots of different types of regressions. These are just, different types of unsupervised and supervised learning. I should mention there is a third set of algorithms called reinforcement learning, and I'm going to talk about that in the next slide. There's some feedback on the audio. I'm just wondering if there's a question or if there's somebody who needs to be on mute. Okay, and then the last bit is deep learning. So this is another class of AI. This is where more to do with kind of, if you think of Google Translate, or if you think of image recognition at Facebook, if you think of advanced neural networks, that's what deep learning is. I don't have much experience with that, and I won't speak more about it. But that's certainly there's an entire semester's worth of topics to talk about in deep learning. So just a quick word on machine learning, right? I've certainly used the words, the terms data science and AI kind of interchangeably. Machine learning kind of falls somewhere in the middle as well. Again, I don't, I'm not here to kind of settle any debates, but the way I think about it is data science is all about models that extract patterns and make some predictions. And I think of machine learning as taking those results, feeding them back into the model, and automatically calibrating them to improve those predictions over time. Right. So that's what I mean by machine learning. And so just to keep that in mind as you think about kind of building your products and improving them over time. So we have our features, we have our different models, the algorithms. There are a bunch of different types of analytics that can happen, right? So and kind of roughly in pecking order, this is what they are, right? So there is there's descriptive analytics, which is basically saying what happened in the past. It's all backward looking, right? It's not forward looking. Predictive analytics, on the other hand, is forward looking. It's making predictions about the future. And then there's this third type of analytics, which is gaining popularity, and it's called prescriptive analytics, which is saying what should I do to achieve an outcome, right? So let's take a couple of quick examples on kind of what these are, right? So descriptive analytics. This is actually the Uber screen. I mean, like, this is the Uber app again, right? And as we said, there's lots of predictive analytics and even prescriptive analytics in Uber. But these are descriptive analytics. This is if you think of most business intelligence dashboards that you have seen, they are all examples of descriptive analytics, right? If you run a like a sales pipeline report in Salesforce, that's an example of descriptive analytics, right? If you have let's say you have mint.com and you that classifies your expenditures into different categories, that's all descriptive analytics. It's all backward looking, and it's telling you things that did happen in the past. This is an example from Salesforce, right? So this is the this is a predictive forecast. So this is a forecast into the future. So you have your line for today, and then you're forecasting into the future how what the prediction is on how you're going to do for the rest of the quarter, let's say, right? So that's an example of predictive analytics. If you have a anytime you look at the weather forecast, that's predictive analytics. You're getting a prediction of whether it's going to rain or not. And I should mention, right? If the weatherman says, bring your umbrella with you tomorrow, that does not mean that's prescriptive, right? That's just making a prediction about whether it's going to rain or not. So what is prescriptive then? So there's a great example of prescriptive analytics, but I've kind of saved that for a later part of my presentation. For now, I just want to say there are different kind of sets of problems that usually get solved with prescriptive analytics, right? So price optimization being one, expert systems being the other one, what if modeling. These are all examples of prescriptive analytics, and again we'll come back to one concrete example of that a little bit later on. Okay. One last slide on kind of data science, and before we start talking about products, and obviously you can't do a data science presentation without some numbers, so this is my one slide with numbers in it. So so bear with me while I walk through this example. It's not terribly complicated, but I think it's really, really important for product managers to understand this, right? So invariably, when you kind of start building products and you start launching products, the first question you'll get asked is, how good is your data science? How accurate is it, right? And so this slide is kind of talking about the answer to that question: how accurate is it? And it turns out that accuracy is there are times when it is important, there are times when it is not important, right? So in this example, what I have is I'm sorry, yeah. So what I have is let's say we are predicting something. Let's say we are predicting again whether customers are buying or not. So I have 170 customers, and I'm predicting that they're going to buy. That's the predicted equals yes. I'm predicting that they're going to buy 70 plus 45 equals 115 times. But of those, only 70 actually ended up buying, 45 didn't buy. The same way, I predicted that these 55 customers wouldn't buy, of which 5 actually did end up buying, right? So what is the accuracy of my predictions? So the accuracy is, there's a formula. This is called, true positives, true negatives, and so on. It turns out that the accuracy here is actually 70%, which is kind of meh, right, when it comes to the accuracy. So it's not all that great. But there are other metrics to kind of look at, right? And the one of the most other, another important one is something called recall, right? So which basically says of all the positives, how many times were you right? That turns out to be a much higher number. It's at it's 93%. There are lots of other metrics, and I won't go into all of them, but there are lots of different metrics that you can get out of this one matrix, which by the way is called a confusion matrix. So which one of these is the most important one? The answer is none. It's really nothing is more important than your business metrics. And so this is a really important point for product managers to keep in mind when you're designing your product and you're talking to your data scientists and you're talking about metrics. Focus on your business metrics and make sure that you are solving for business metrics rather than kind of what I call vanity statistics, right? So that was the import of this slide. Okay, so let's go on to talking about designing products with data science and kind of my recipe for success or strategies for success, right? So the first question I often get is, right, how does product management change in the face of data science? And the short answer is it doesn't, right? At the core of it, product management kind of, still stays the same, right? Be obsessed with your, about your customers. Have deep empathy for your customers and their use cases. Focus on solving their pain points. Focus on driving value to the user, right? Be data driven, right? Focus on, again, the business metrics. So these fundamentals do not change. And so to illustrate that, I have these two examples, right? So one is the consumer app, which is actually happens to be the Uber driver app. And the other one is, again, Salesforce, right? And so two very different use cases, completely different ways of solving the problem. On the left side, you were seeing a simple screen. The driver is waiting for a customer, right? And that's all they care about, and that's the and that's what we want to solve for, right? So we're not showing a ranking of different places that they might wait at and a probability or confidence levels of where, which customer will show up or which customer will cancel their trip. It's just a very simple interface. On the other side, you have this screenshot of a lead again from Salesforce, right? And what the user wants is really a ranking of leads. Which leads are the best ones that I should go after? And so that's why I have a lead score, and I have some more explanations of what makes that lead a 92, versus some lower score, right? And so my key takeaway for this, for this slide is data science is just a means to an end, right? Focus on solving the use case at hand, and everything else will follow, right? Second one, and I have 10 of these, by the way. So the second one is actually nothing to do with data science. It's all to do about data, right? And the data that you get will not be clean, guaranteed, right? And the challenge is to get the data cleansed, which is a really hard thing to do. But it's the single best thing that you can do for your data. And and if you can cleanse your data, the incremental benefits that you get out of that will be way more than any kind of incremental gains that you'll get from a quote unquote better model or algorithm, right? So get your data house in order first, right? Third one, and we kind of talk about this often in other contexts, right? Low-hanging fruit, right? What's the low-hanging fruit for data science? It often is choose the simplest model. You don't need to overthink it, right? And don't let your data scientists tell you otherwise. I have data scientists who will say, oh, the models are not ready yet. Let's refine it further. before we actually, get it out. I think that's a mistake, right? That leads to analysis paralysis, right? And, you'll be surprised how far you can get with just very basic, simple algorithms. So that's also something, to keep in mind. So there's no math involved, even though there are some numbers here. I think of people will say about design, right? You get the good, best design is when design is out of the way. And it's kind of the same thing with AI as well, right? The best AI is when AI is really out of the way. How do you, the task at hand is how do you make your AI or data science, right, consumable for your users, right? So in this example, let's say, again, this is some Salesforce example. Let's say you're scoring different opportunities, right? And you're coming up with some probability number or a score, and I have 3 different opportunities, 3 different scores, right? Versus I can just bucket those probability numbers into what I call traffic lights or t-shirt sizing, right? High, medium, low. How important is it for a user to know that a particular opportunity is a 68% versus a 73%, right? It's not. Right, what users really just care about is just tell me, what are the high, medium, lows, and they can do other stuff with it. They can group these, the high opportunities together and do some, stuff with them. So the cognitive ability that is required, or the effort required to, when you're looking at, a whole bunch of these opportunities is much lower when you kind of, take out the numbers and kind of, just make it simple for the user. So, getting the AI out of the way is really important, and so think about, how are your users going to consume your AI when you think about it. But so then to continue on with the example, right? So, getting it out of the way is nice, but you also, want to make it actionable. Your users will ask for that. They'll say, "Oh, give me actionable insights," and product managers will often say, our product provides actionable insights, right? So what is it that makes an insight actionable, right? Is this actionable, right? When I have a bunch of opportunities and a bunch of scores and they're high, medium, low, is it actionable? Yeah, you could argue, that, it gives you a little bit of information, but how do you answer the so what question, right? The user is going to say, okay, I have an opportunity which is a low. So what? What do I do with it, right? How do you make, what is the user going to do with that information? And so what you have is, can you provide what I call interpretability of your data, right? How do you make it, how do you explain that an opportunity is a medium, right? So the use case is that a user wants to take a medium opportunity and make it a high opportunity, or a low opportunity to a medium, right? They want to move up, and so for that, they want to know, how do I impact that opportunity? And so that's what we are talking about here. Focus on kind of, providing, don't make your AI a black box, right? Because it's not going to work, particularly in the enterprise context. Now, all of this is obviously caveated by the fact that in a consumer use case, you might have a very different use case. Okay. Okay, and again, you'll see some of this in other products, right? You'll see kind of like, why did we recommend this type of hints in retail applications, for example, right? So that's the making the insight consumable is what we're about. This is one of my favorites because it also, I've seen the most egregious kind of violations of this principle, right? Your users are lay users, they're not data scientists. So don't design a product for data scientists, design the product for your user, right? This is a real life example. I once had a manager who wanted to create this complex stockbroker's chart for a sales user. And, we certainly had a lot of data that we could show, and we could create, confidence bands and these, candlestick diagrams, but it would create a really complex chart. And, our sales guy, we were, designing this application for a sales user, they wouldn't even look at this twice, right? So it's much better to show less, right? Cut it down, show what is the least amount of information that you can show and start there, right? More data is not necessarily insightful. And so, this is not an apples for apples comparison, but what I'm showing here is, this is a case in Service Cloud in Salesforce, right? And what they're showing is a predictive close time, right? There's no there's no chart, first of all. It's just a simple English language sentence that says, we estimate that this case is going to close in 5 hours and 8 days, 5 days and 8 hours. And there's no confidence levels, there's no margin of error, right? And it says, hey, it's 45% longer than resolution time. I'm assuming that that's, average resolution time. It's really simple for the user to grok, and you don't have to have the user go and make their own interpretations of a complex chart, right? Again, not apples for apples, but I just wanted to kind of make that distinction clear. You also have a couple of recommendations here at the bottom, and so this is basically saying if somebody says my router is not responding, what can you respond with? And users, this is data science in the back end, right? You have a score for these different responses. By the way, this is probably supervised learning in the back end that collects these responses and tells you which one is more appropriate for the other. And then there are some descriptive statistics, right? So the 984 times that thing has been viewed is not data science. I mean, it's just saying, that template was used 984 times, but it makes it powerful for the user to understand why a certain thing is being scored a certain way. Okay, so again, design your interface for your users, solve a problem, don't design it, don't make it complex, and don't design it for data scientists. Okay, all right, so the principles so far, we won't design a product that's complex, we'll convey this to, insights in the, in the simplest way possible, but you're definitely going to be in situations where, you're going to want to show a bunch of data, you want to show a bunch of numbers, you want to show a bunch of insights, right? So what do? So another Salesforce screen, this is on, this is a Marketing Cloud screen, and I want to kind of, deconstruct that a little bit, right? So you started, let's start with the trend arrows, right? This is a great way to succinctly show a bunch of data. You're saying that, you can barely read this, but this is basically the loyalist segment, and we're saying that, there's an uptick from the previous period. What is missing in this UI, and I think that's it's a miss, which is that it doesn't tell me over what time period in this particular instance. So I would correct that. But other than that, this is good. Here's another kind of trend arrow, right? In this case, the magnitude of the change is kind of shown, so that's great. It also shows me versus last week, so that's good too. The important bit here that I wanted to kind of talk about is that this cadence is really critical for your users, right? And you really have to get into the mind of your users. How often are the users going to come and use your product? What is that delta that you want to show? What is the business cycle that they're kind of that you are solving for, right? So it's not as trivial as it may sound, right? So that's an important kind of consideration. You have this view details, which is a drill down, which is excellent, which is you don't have to show all of the information up front. Let the user summarize the information for the user, then let them drill down for more details. Now the art as the product manager is going to be to figure out what gets summarized and what is in the details, right? But so this is but it's really important to kind of think of that when you're designing your product. Again, kind of coming back here, and I apologize for the resolution of the image, but you have a bunch of different categories here. There's there are loyalists, there's window shoppers, and these are win backs or dormants, right? These are probably maybe they are outputs of your clustering that you're doing, right? And so give it names, right? Because users like to name things, right? And you can do things with with categories, right? So so giving it names is a good idea. And then a couple of kind of UI related stuff, right? This is what we call progressive disclosure, right? Which is that again, this idea that you don't have to show everything at once. Let the user progressively see more information as they interact with your product. And so again, to do this right, you really need to get into your user's head and really understand how they're going to use the product to do this well. Same thing, kind of, well, similar thing here, with a toggle, right? It's basically toggling between actuals and percentages. This is a good way to kind of, again, keep it uncluttered, right? You don't have to show the numbers and the percentages all at once. Just make it simpler. So this is really just more about design, right? And less about the data science itself. But the design and AI do go hand in hand, and I'm going to talk a little bit more about that when we talk about engaging with data science teams and so on. Shifting gears slightly, right? So I've used the word user a lot. There are other types of users. Let's call them managers, right? So these are, higher, managers or upper management in general, right? And there are slightly different considerations for them, right? Again, less is still more. I mean, this is a recurring theme in my recipes, right? Less is still more. You want to, but it's even more important at the manager level, right? You do not want to show all the details, right? Just show them the key insights, right? But then you provide the interface for them to be able to drill down, right, as needed. Articulate the insights, right? Don't show a chart and let the user figure out what the insight is. Tell them what the insight is, in English if appropriate, right? Something that I haven't talked about yet is this idea of anomaly detection, which is exactly what it sounds like. If you have anomalies, kind of alerting the users to that. This is really great for management by exception, right? So think about incorporating that in your products. As we saw in the prior example, if you're using clustering, it's often insightful to kind of expose that and let the users really interact with that clustering output, right? And I said that I was going to talk about prescriptive analytics just very briefly. Just a great, if somewhat infamous example of prescriptive analytics is search pricing from Uber, right? Managers really like prescriptive analytics because it tells them what to do to achieve an outcome. So it's very, very actionable. And so think about that. I mean, and it obviously depends on the use case that you're trying to solve for. Number 9 is around visualization of data. So this has become a hot topic in data science, and lots of people kind of talk about it as kind of visual storytelling, right? And it's really the key there is to how do you tell a good story, right? So there are lots of tools out there, and you can pick up the tools, but really the art is in the technique. And again, this is one of those things where you could do an entire quarter or semester's worth of a course on just the techniques of data visualization. So I won't speak too much more about it. The one book that I really recommend is this one by Tufte. It's considered the Bible by many. So highly recommend that. Just a kind of a brief. I have these 2 screenshots on the right side. I just picked them up, as random dashboards from Google image search. I don't even know if these are built for managers, but let's assume that they are. In which case, the one at the top, I find it hard to kind of read. I mean, it doesn't tell me a story. I don't know if there's a happy ending or if it's a tragedy, right? And there's like some interactive things going on here with the hovers. And whereas this one seems much cleaner to me. It tells me a story. I'm exactly halfway to where I want to be. So again, just the 30 seconds on this, and it totally doesn't do it justice, but it's important. But it's a really important thing to keep in mind. Okay. The last one is KP is QA, right? So just like any other product that you're going to manage, you need to manage this product, and you want to do QA on it, right? So how do you know that the AI is working, right? So there are two kind of 2 buckets, if you will, right? First one is go back to your KPIs, right? If you are solving for let's say lead conversion, then are you impacting lead conversion in a meaningful way, right? Go back to your to the business metrics. Go back to your usage metrics, right? Are your users using the product? Are they coming back and using the features that you have that you have defined with AI, right? The adoption metrics that you have defined, right? So those are all great. And and then by the way, go and ask your customers if they're how happy are they with the product, right? I mean, there's nothing like getting it validated with your customers, right? So there's nothing well, I mean, until we come to backtesting, there's nothing special about the KPIs and metrics, with data science products. They're, very much, the same thing that you've been doing so far. The one difference is that there is this idea of backtesting, and I think I removed this slide on backtesting is just in interest of time. But what you want to, let's see, okay, well, I do have it. I think I'm going to actually skip over this for now. I don't want to get into the details of how backtesting happens, but and I'll put these slides up later on so you have that. The idea is that you want to be able to establish a baseline for your data science algorithms, right? Not just for data scientists and engineers, but really as a product organization, as a sales and customer success organization, you want to be able to use those backtesting results as proof points, right? It's become very much the norm in kind of when you're onboarding customers, you use your backtesting results to show how well your data science is working or not. So so I'd encourage everybody, or product managers working with data science products to really understand how backtesting happens. Go look at some of the results from your data science team and incorporate that as part of your kind of arsenal for products. Okay, so that was the strategies for success. I'm going to spend a couple of slides on kind of pitfalls before we go on to kind of beyond the product topics. So first one, we talk about big data all the time in the context of data science, particularly for enterprise systems. The amount of data may not necessarily be all that big, right? Especially data that gives you signal is not all that big, right? So for example, I've been using these Salesforce examples. A year's worth of opportunities data, not a year, but 10 years worth of opportunities data is still not as much as, let's say a month's worth of some IoT sensor data, or, probably even a day's worth of Uber data, right? And yet you can make lots of useful predictions from that relatively small amount of data. So that's something to kind of keep in mind. When you think about whether or not to use data science, you will be asked, do you have enough data? Well, what is enough, right? So that is something that you need to keep in mind. And then more data also doesn't necessarily mean better predictions. There's this quote unquote sophisticated users will say, oh, what if you plug in more data sources to drive better predictability? Well, that doesn't always pan out, right? Your data might be you might be getting very old data which is just completely out of date. It might actually hurt your predictions. Or if you're plugging in more data sources which have poor signal to noise ratio, then again, all you're doing is making your system less performant. You're not necessarily making your predictions better, right? So so be careful about what data you should be using for your products. And then finally, data science is not a silver bullet. What I'm showing here is this old dashboard from Salesforce, right? And the reason I selected an old image is because there's a new UX now. There's the lightning experience, and there's new dashboards. But fundamentally, the metrics that we're showing, these pipeline metrics are unchanged, right? From a decade ago. These are still the metrics that salespeople do need, and that's the thing that they act upon. And so there's no reason to shy away from just simple analytics, just because hey, it's not data science, right? So you don't. Again, I said it before. Data science is a means to an end. You don't. You shouldn't. It's not an end in itself. Okay, so let's shift gears a little bit and kind of coming up on the tail end of the presentation. But I want to spend some time talking about how do you engage with data science teams, because I think that it really makes the difference with making for a good product and not, right? So think of data science as an integral part of your product and engineering team. I think of them as no different from my engineering team, right? It's just they're plus, but a lot of data science is really software engineering, right? So make them an integral part of your team. They should be part of all your normal kind of sprints and all the rituals that you do with Scrum in terms of sprint planning and daily stand-ups and all of that. There's no reason to kind of treat them differently, right? And so that's one. Second, just like design, right? I always bring my designers into customer conversations really early on. In the same way, don't hesitate to bring data science into customer conversations early on. That said, you're not asking them to be product managers. You're asking them to be there in their data science capacity, but bring them in early so that you can help them understand what the problems are. And I'm going to talk about that in my second slide. And when you are road mapping, drive use case based initiatives with data science, right? There might be stuff that data science wants to do. I mean, treat that as technical debt that you might have with your other engineering team. But anything that you really want to drive from a use case perspective, make sure that it's use case based. And so this, so that was kind of more on the structure and kind of, strategies. This is more about kind of on a day-to-day basis, right? Again, the conversations that you should be having with your data science team is to understand the user's problem, define the problem, help them with the art part, right? And leave the science to them, right? So in most cases, data science should be picking the algorithm, right? I don't know if product managers should be picking, whether to use random forest or gradient boosted machines, right? It doesn't make sense. So help them understand the context, which will assist them in the, in their feature selection. Kind of like API design, agree early on, kind of what is the input into the system, what is the output into the system. So design it much like anything else. And again, don't forget the UX part of it. I mean, you need to bridge the gap between design and data science. And again, I've said this maybe for the third time, reinforce business metrics, right? Make sure that you're solving for business metrics, not for accuracy of algorithms. Okay, product marketing. I think of my career, product marketing has been a very core part of product management because nobody's a better spokesperson for your product than yourself, right? So when it comes to data science, you need to learn to speak data science, right? And which means you need to know when do you mention data science and when do you not. There are times when you need to say it's data science, and there are times when it's not needed. When you do speak about it, how much do you kind of give away, right? And so I'm going to speak to that on the next slide. And how do you explain what might be complicated algorithms in the back end? So for that, you need to understand your audience and understand context, right? I think, this might be simplistic, but in the consumer app world, right, it might be okay just to say, hey, it's powered by sophisticated AI, and that's the end of it, right? You don't explain how Uber does their, driver positioning because nobody cares, right? It just works. On the business app side, not so much, right? Your users, might have been doing something, the same thing for the last 40 years, and you're coming up with a newfangled way of doing, of solving that with AI. Well, you're going to have to explain why it works and why it's better than their system, and then you have to do it in a diplomatic manner, right? So you need to understand the context of the user and what to say and how to say it, right? Check with your data science team, check with your legal team, check with your, IP lawyers, right? I mean, in general, what I find is that the general approach is absolutely acceptable, right? But you may not want to get into too many details, right? That said, usually the IP is not in kind of, hey, what's the model that you use? We use, kernel regression with smoothing. That's not the that's not the IP. The IP is really in the whole end-to-end solution that you put together. So it's something to be balanced out in terms of what you should talk about, how much you should talk about, and make them simple explanations. Just like anything else in life, keep it simple, and be prepared to back up your claims. Right? AI is still kind of new. People will be skeptical, and rightly so. Back it up with proof points. That might be backtesting, but it also just might be good old customer references, right? Have your customers speak about the efficacy of your data science, right? And okay, so that brings us to the end of the presentation. I have one last slide on what I consider kind of a toolkit for product managers. I think a background in kind of basic statistics is a must, right? So if you don't have that, I would highly recommend getting, a primer on statistics. Pick up a book on, high-level data science. One of the books I've recommended is the Data Science for Dummies. There's another great book called Numbsense, which is, with no math added. That's another great book. And Intro to Data Science, online course, and there are plenty of them. I'm sure there are free ones and free videos. I mean, I would highly recommend, doing that. I mean, at the end of the day, if you're going to build data science products, I think you should know a little bit about data science. You don't have to code, but you should know enough about data science to have conversations with your data scientists, and they will, respect you for that. I wish there was a prototyping tool, just like on the design side, I've used Balsamic or Sketch. Unfortunately, on the data science side, there isn't anything unless you consider kind of Jupyter Notebooks, a prototyping tool, which they are, but that also requires a little bit of code. In any case, it might be useful to kind of be able to kind of see distributions and curves and make some sense of that. Excel is is always your friend, so you should be don't be shy to use that. And then finally, if there's one key takeaway from this entire presentation, it's this, which is make friends with your data scientists, right? Collaborate with them, just like you would with the other engineers and your designers, right? You're the leader of the product team. Make sure that you collaborate really well with everybody on your team. So that's it for me. Thank you, and let's open it up for questions. I think we have about 10 minutes left. Would love to answer any questions that might have come in, and obviously I can also answer questions offline. If there are any, please feel free to reach out to me. Padmaja?
Yes, Mandar. Thank you. That was a great webinar. So we'll go to questions now. Pinkesh, are you online?
Yes, this was phenomenal, Mandar. Great job. I think I was monitoring some of the questions that 100+ participants were asking, and what's phenomenal is that just like any other good data science project, you were actually predicting what questions are going to be asked and answering them in real time. So this is phenomenal. I'm going to take a few that I've heard from the community as well in the past, and from the live stream that I think the team has shared here with me. But I'm going to first start with this question that gets asked a lot, right? There's a lot of examples you used, which are obviously from the high-tech industry, and data science is generally considered a kind of more digital technique. Are there examples in your mind from an industry agnostic perspective where you've also seen successful or failed implementations of data science in non-high tech? And I think Jainendra asks a very similar question to say, hey, look, how do you do data science on an offline data or something that's not live stream?
No, absolutely, and that's a great plug for my current company, Entytle, because we are absolutely in a completely non high tech industry, right? So we are, as I said, we are servicing industrial manufacturers, right? So these are think of them as the large the Caterpillars of the world, and Ingersoll Rand, and these are companies that make industrial refrigerant solutions and oil drilling equipment and so on and so forth, right? So absolutely non-high tech, and there's no, and it's all offline. And the beauty of it is that absolutely we are being, I hope we're being very effective at doing data science for them. So let me, kind of briefly, just by way of example. All these companies have a ton of data about their customers. They have, this is a huge market. It's a $500 billion market, and it's completely underserved, by the way. And they have a lot of data in terms of, and I'm not even talking about IoT and streaming data, right? Let's just ignore IoT for the time being. And this is just, all of the, historical orders that they have placed over the last 25 years, all of the parts and services that they have sold after the sale. There is ERP data, there is service data, there is call center data, there is CRM data. There is so much data there, that it's really not just about kind of the ability to kind of get at the data, but there is absolutely use cases to be solved for with data science, right? For example, we make predictions for those companies in terms of which customer is going to buy the next part, or which part is going to fail for them based on equipment that they bought 25 years ago, and on again, we make predictions about how often that equipment is depreciating over time and so on, right? So so there's complex use cases and lots of good a complex, sophisticated data science that can solve those problems.
Yeah, I think I recently was talking to an alumni who's at Bosch, and they were actually doing fairly nifty things about predictive failure, obviously in the device itself, to say, hey, at what point the turbine is going to fail, using using sensors. So that's good to know. Another, and just looking at this live stream here, and obviously there's a lot here, so I'm trying to segregate them into kind of tech questions or natural categories. But one that kind of stands out here is the whole notion of data cleaning. I think you mentioned, obviously it's very critical. You know, the good old saying of garbage in, garbage out. Right. If your data is not clean, your predictions are only that much more useful. Now, how do you know? How do you know when something is clean, right? And I think Sunil asked that question, and I think a couple others asked the question. And are there some specific tools that you would recommend for the cleansing part as they start their data science journey?
Right. Okay. So there's two or three parts to that question. So let me maybe start with the last one, which is tools. There are definitely plenty of tools out there. In my experience, unfortunately, at least on the enterprise side, I haven't found a good horizontal solution that solves all of our needs. And so we invariably, and I've talked to other colleagues of mine. I mean, we what I've seen is that invariably companies will have to kind of build their own kind of custom solutions. So so unfortunately, I'm not able to recommend a solution just because we don't use one in house. But I mean, there's certainly plenty of them out there. There are also open source solutions out there which are certainly good, and they can be good starting points. Second, you asked about how do you know your data is clean? Well, I mean so there are data quality type of algorithms that you can that your data science team can help you with to build that which basically takes a small sample of your data and kind of predicts how clean your data is, or what the signal to noise ratio is, right? So that is something that you would have to kind of build. I mean, again, there's no there's no simple answer there. And then the third part is that, yeah, I mean, data cleansing is incredibly critical, and I'd say we spend probably more time doing data cleansing than we spend on data science itself, right? So making the predictions, or or at least an equal amount of time. So it cannot be overemphasized, the need for data cleansing. Now there are lots of different techniques, right? So you can do cleansing, you can do deduplication, you can do data enrichment, you can connect to other data sources to actually help clean up your data. It really depends on the use case, and you have to sit with your data scientists and go through the data and figure out what you need and how to get started.
That's brilliant. And again, I think there was a lot of questions on, especially when you are having data which are, clickstream data, real time. Some of it will be highly impure, if that's a term that we can use, right? So that certainly helps. Now, speaking about time, and you made a very interesting comment, and just picking off from there with a bunch of questions that have also been asked is, you mentioned that you almost want to spend half of your time or more in cleansing as much as you do in the algorithmic side. What is, how do you build, if I paraphrase this question, bring this up a little bit higher, obviously Balaji and many others have asked here as well, how do you make a business case? What kind of budget do you put in? What are some best practices on how much time and money do you recommend your company, if you're working inside a company as a product leader? How do you make the business case and say, hey, look, I need X units of time, Y dollars to explore if we can bring data science into the products, or using your definition, data, make our products data enabled?
Right. So that's definitely a loaded question. I mean, so I would say yes, meaning that do build a business case for it, right? So that's the first thing, because you don't want to willy-nilly kind of go down this path, because it is resource and time and effort intensive, right? And so it's not going to be a cheap solution, right? So if there were kind of, off the shelf, kind of data science tools that you could kind of plug in and play, I mean, if you can find those and if they're applicable for you, more power to you. But I mean, it all boils down to your business use case, what you're trying to solve for. And it really depends on, what is your, what is your ASP? I mean, are you selling, I mean, what is your business model, I should say, right? And then, I mean, try to get at kind of, what is the incremental gain that you're going to get from, putting together a data science kind of solution, right? What is the status quo, and where do you want to get to, right? And yeah, I mean, looking at cost, right? I mean, you could kind of build a cost calculator in terms of the amount of resources that you need, and the expected incremental gain that you're going to get out of it. You want to think about it in terms of either productivity or top line, or or cost savings to the end user, and how much of that you can translate into kind of rev share for your product, right? So you can, I mean, build those ROI models, but I think if when the user says building a business case, I mean, I think it's very critical to build a business case. So that's the first starting point.
Good point. And I think what you're also reiterating, which is very important, sometimes that people ignore that advice or take it lightly, is this is not a let's do some quick fix and put the label that we are now doing some data science, right? I mean, I think you need to have the right skills, not just the skills in terms of the infrastructure and tools, everything from all the buzzwords, from Cassandra to others, but also the skills to visualize that data, communicate the value and the business case for it, because without which you will be in a half-started journey.
No, absolutely right. I fully concur with that. I think the biggest part of that is really the skill sets, right? I mean, you need, I mean, getting a good data science team together, it will be your biggest challenge. So you really want to pay attention to what you're signing up for.
So that's a good segue into the next set of questions that I've also seen here in the stream, but also from others in the past. This whole notion of careers, in this space. Now, if you have these circles, if you will, at some point they will overlap, and there's probably an intersection, right? So there's a data scientist. We hear terms like data smart manager. We hear terms like business intelligence, or business analyst, who or data analyst. And while those titles might still be buzzwords, and while they're still getting formed in different companies, might have different context on what those means. In your experience, I mean, you have a very unique perspective, not only that you have been doing this hands-on from the industry, but you're actually now, when I met you last, you said, hey, look, you're also running engineering in your current role. And so how much of that, engineering and product management intersection, how much of that data science and product management intersection you recommend for people who are wanting to be the next Mandar, right? Or wanting to look at a role model and say, hey, look, if I need to move up there, what do I need to do? What's your advice?
Yeah, I mean, so I'd say, put titles aside, right? I mean, as a product manager, you are the leader of your product team, right? And so you need to, kind of, I think of it as you're like a mini CEO. You need to do everything, right? So the short answer to the question is kind of all of the above, right? So don't be kind of pigeonholed into just doing, I just do product management, and somebody else does product marketing, and somebody else does design, and somebody else does data science, right? You need to kind of, bring yourself to the intersection of that Venn diagram and kind of say, you're really taking on everything, right? Which doesn't mean that you have to do all the work, right? But you have to corral the resources. You have to, definitely have an understanding of, the underlying kind of stuff, right? Which is, I mean, like today's webinar, right? I mean, I think understanding the basics of data science, that's important. Understanding, the basics of design is important, right? Again, I mean, yeah, I mean, I don't think it's that unusual now. We're seeing this more and more, kind of, the types of roles that I'm doing, where, product and engineering are all rolled up under one organization. It's not unusual. I would say, focus on kind of being the product leader that you want to be, and then do everything that you need to do to make that happen.
So maybe a more pointed question on this, Mandar. So when you're hiring for a product manager, when you're looking to add somebody to the team, what is your perspective, and just beyond, obviously you've been in Salesforce, you've been in many other companies in the Valley, and now in this hot startup Entitled, but even moving forward, how much data science, how much of that is necessary for a product manager to be even competitive, to be exciting for the so-called hiring manager to show? And second follow-up question is, what would be the demonstrable skills that you would want to see when you are hiring, when you're looking for it? What would be three things you would ask in an interview to know whether he or she knows enough data science?
Right. So,
Professor Shah and Mandar, I hate to interject, but we are at 10:06. So we need to start taking the questions offline.
Super. We'll maybe wrap this up with this last question then.
Sure.
Yes.
Okay. Super.
Thanks.
Sounds good. Yeah. So really quickly, I mean, what do I look for? What am I excited by? So I definitely want to see some kind of data science related projects, if you will, right? So for somebody starting out, take up a project, right? Get yourself aligned with some project inside your company that does some amount of data science, because I think that is critical. Having a data science mindset is important, right? So being able to demonstrate that you understand the metrics that I talked about, like the fact that accuracy isn't always the most important thing. Just having that perspective is really critical. That said, you do not need to code, right? I mean, having a technical background is definitely helpful, but I don't, that shouldn't limit you to a career in product management and data science, right? So that's kind of my take on it.
Brilliant. I know there's a lot more questions pouring in. I see Manjunath, Asit, Kshitij, Ambrish, Karthi, and many others, Sharda. So I think it was a fantastic, fast and furious, certainly very, very informative. I know I certainly learned a lot. I'm sure the audience did as well, and so truly appreciate your help.
No, thank you very much for giving me the opportunity. And again, I'll be very happy to answer those questions offline. So please forward them on to me, and I'll be happy to kind of take them offline.
Excellent. Over back to you, Padmaja.
Thank you, Professor Shah. Thank you, Mandar, for an absolutely fascinating webinar. I think the testament to that is that we had over 100 attendees, and we actually maxed out on the number who could attend. So for those of you who tried to come in late and could not, I apologize remotely. So very quickly, here's our LinkedIn group. Please do join if you're not already a member. Post your questions for Mandar. He has so very graciously offered to answer your questions over there. So do interact with Mandar on the LinkedIn group. I'd also like to announce that we, during the webinar, we had quite a few people join the group and post questions for Mandar already. Of them, Jainendra Kumar, Kshitij, and Manjunath Subramanian. You will have discount coupons heading your way, so you can try out our brand new e-learning course on product management fundamentals. The best question award, the lucky winner among so many questioners, we had over 30 or 35 questions at the last count, is Ashok Sharma. Ashok, you will get Data Science for Dummies. That is the book recommended by Mandar to get started on the data science journey. A quick note on the upcoming prod events. We have another fascinating webinar on Ideation next week, Transforming Unlimited Thoughts into One Winning Idea by Professor Naveen Lakoor. We have an online info session coming up, hosted by Professor Rahul Abhyankar. We also have, towards the end of April, on 22nd April to be precise, a day in the life of a product manager seminar, our most popular seminar series that we hold across the country. And this time we have a very elite panel as well as a workshop in the afternoon. So if you're going to be in Hyderabad on 22nd April, please do register. And finally, 6th of May is the next edition of the seminar, which will be in Gurgaon. All details are available on the events page at www.productleadership.com. That brings us to the end of tonight's seminar. We hope you all enjoyed it as much as we did. Thank you very much. Good night for people in India, and good day to the others abroad. Thank you.
Thank
Bye.
you.